Okay, the initial angular momentum is equal to the final angular momentum. That is, I put I omega I. You can use I1 omega 1 if that's more convenient. So I1 omega 1 is equal to I2 omega 2, isn't it? And so make IF the subject, because it says by what factor. So you get that as the formula. Rearranging. Plug in the numbers. It's 1.3 and 0.8. And you get it as 1.625 I1. There you go. The final moment of inertia is 1.625 times the initial moment of inertia, isn't it? So what is the answer? Your answer is it has changed by a factor of that much, 1.625. So that is your answer. All right, again, Li is equal to Lf. So initial angular momentum is equal to final angular momentum. And again, the same formula. And here you got to find her final moment of inertia. So you make IF the subject, isn't it? You have to find IF. Make IF the subject. Rearrange that. So the omega F goes to the denominator there. And then before you plug in, you got to think, all right, the initial is given as 4.6, and I want to stop there, and that's what I was trying to explain. Actually, we know omega is 2 pi times F, isn't it? Why didn't I put the 2 pi? It's going to be canceling out, isn't it? Because the 2 pi is going to come with omega I and also down in the denominator. So if you want, you can write it down to be perfect and then cancel it out. But did you understand how I got the 0.5? One rotation every 2 seconds, which means half rotation in 1 second. Okay, let's go on. And so that is the final answer, 0.77. So what you got, if you had divided by 2, you would have got the right answer. The idea is still the same, conservation of angular momentum. I1 omega 1 is I2 omega 2. We are asked to find the new frequencies, so I decided to find omega 2 first. Is that the equation for omega 2? Sure. When you rearrange, and then I1 is 1/2 5 times 0.2, because that's half of the diameter radius squared. So you will get 0.1 kilogram meter squared. Anybody got that?
Yeah.
Sure? Okay. So that's what's your final moment of inertia? Because what does this guy do? He takes a 3.1 kilogram chunk of clay, and it's approximately shaped as a flat disc of radius 8 centimeter, and he throws it onto the center of that thing, right? Come on. So the radius is given and the mass is given. Can you find the moment of inertia of that thing now? The clay? Find it. What is the moment of inertia of clay? Just put it as I clay. Just put I of clay. Because that's a disk, isn't it? Same formula, 1/2 mr squared. So that will be 1/2 times 3.1 times 0.08 squared, because 8 is in centimeter. And the reason why I'm not showing you what I've written is because I want to ask you a question. Once you get that answer, what do you get for that? Moment of inertia of clay, what did you get? 0.0092 kilogram meter squared. Now I want to ask you, what's the new moment of inertia of both of them together? You already have the wheel rotating, isn't it? And on top of that, you threw the clay. So now what you got to do is add them up. So that would be your I2. So your I2 would be 0.1, which is already there, plus 1.5 times C is the clay thing, okay, which you already found out, and you said, let's see. I remember that the answer was correct, whatever you said, 0.08 squared. Didn't you get 0.00992? Isn't that what you said? Okay. So when you add them up, you get the new moment of inertia. That is the new moment of inertia. What next? I1 omega 1 is equal to I2 omega 2. So next what you do is, to find omega 2, I've already written I1 omega on top, so I just have to plug in the numbers. 0.1 times 1.5 times 2 pi. This time I put the 2 pi also, although it will get cancelled. That is the answer. 1.36 rotations per second. Did you notice that I had to divide it by 2 pi after that? Yeah, because of the formula, and because the question asks you to find the frequency, not the angular speed, right? To get the frequency, I had to divide it by 2 pi. All right. Number 4, angular momentum is the product of moment of inertia and angular velocity. It's a cylinder, so it's 1.5 mr squared times omega. 1.5 times 55 times, I hope you changed centimeter into meter, did you? 0.15 square that. 3.5 times 2 pi, because omega is 2 pi f, isn't it? Okay. Put all those into your calculator and you get 14 kilogram meter squared. Did anybody get that? Okay. Remember, that's angular momentum, therefore look at the unit. Take a close look at the unit. Do you notice the unit? It's not kilogram meter squared, it's kilogram meter squared per second. Okay. Torque is change in angular momentum divided by time. 0 minus 14 to be perfect, because the final is 0, the initial is 14, divided by 5, which is negative 2.7. Take note of the unit. What is that? Meter Newton. Newton meter will also work. Here we go to number 5. You've already done it and you're all good. So initial angular is equal to final angular momentum. Yeah, I just wrote it as platform, then I decided to put PL, I think, yeah. Because for the person and okay, now I decided I will put it as P. Platform. I'm trying to do it in one step, but you get the idea. It's the same thing. Okay, 920 divided by 920 plus. What did you get for that, guys? 75 times 3 squared, which is 9. So times 2 was the original angular velocity. So I got 1.154 radians per second. Did anybody get that? Okay. Because you're supposed to find the rotational kinetic energy before and after. Did you notice that? Okay, so I'm finding the kinetic energy before, that's initial. That's 1/2 times I of the platform, omega squared. Plug in the numbers. I got 1840 joules. Because it's just 920 times 2 squared. 4. And then to find the final, same formula. But remember that you have to add up the total moment of inertia of both platform and the person, like we did before. And we got the final angular velocity is 1.154, so square that, 1062 joules. Did you notice that energy was lost? Right? Can you explain how the energy was lost? How? How was the energy lost? What's the person doing? The person is walking. Isn't there going to be friction when he walks? The question said there was no friction when the platform was rotating. It didn't say that there's no friction when he was walking, because without friction, the person cannot walk. Especially on a rotating platform. You try that. Without friction. That's why the energy was lost. So number 6. I1 is 1760 kilogram meter squared. Omega 1 is given as 0.8 radians per second. I2 is this number plus 4 times mr squared. That's 65 times 2.1 squared. And that you will get 2906.6 kilogram meter squared. And you have to find the final angular velocity. So again, use I1 omega 1 is I2 omega 2, isn't it? Plug those numbers in and you should get it. Omega 2 is I1 omega 1 divided by I2. And you get 0.48 radians per second. I1 omega 1 is equal to I2 omega 2. And you're looking for omega 2, so omega 2 is I1 omega 1 divided by I2. And plug in the numbers, that is 2906.6 times omega 1 is 0.80 divided by 1760, and you get the answer as 1.32 radian per second. Thank you.